Good afternoon, everyone. Today I'm going to talk about the data structures. Data structures. What is data structures? Structuring the data into the memory is nothing but data structures. Normally, we organize the data into the memory so that we can access it very quickly as well as using the memory space less. We have different types of data structures. We have different types of data structures. That is primitive data structure as well as non-primitive data structure. Primitive data structure. Primitive data structure is nothing but it can hold only a single value. It's nothing but primitive data structures. For example, integer, float, character, boolean, pointers, these all comes under primitive data structures. If you say int a equals to 10, that is here the variable a can hold only a single value, which is a type integer. The same goes to float. Float is nothing but the decimal point values. The character is nothing but the character value which can we can hold it. The next pointer. What is pointer? Pointer is nothing but it is a variable which holds address of another variable. These all comes under primitive data structure. That is nothing but which holds a single data value. Nothing but primitive data structure. Now let's go to non-primitive data structure. Non-primitive data structure is nothing but which can hold more than single value. That is non-primitive data structure. Now in non-primitive data structure, we have two types. That is linear data structure as well as non-linear data structure. Linear data structure. Linear data structure means that here the data is arranged in sequential manner is nothing but linear data structure. That is the arrangement of data in sequential manner is nothing but linear data structure. That is one element is connected to only one another element is nothing but linear data structure. Now let's go to nonlinear data structure. Nonlinear data structure means here one element is connected to n number of elements. That is, here we are considering an element which is connected to n number of elements. It's nothing but non-linear data structure. Non-linear data structure examples are trees, graphs. These all comes under non-linear data structure. Now let's go for linear data structure. In linear data structure, which is again classified into two types. That is static data structure as well as dynamic data structure. Now, static data structure. Static data structure is nothing but it is a type of data structure where the size is allocated at the compile time. That is, here the size allocation is done at the compile time. Therefore, the maximum size is fixed. Here, the dynamic data structure. Dynamic data structure is nothing but a type of data structure where the size is allocated at the runtime. Your allocation of size is done at the runtime. It is nothing but dynamic data structure. Therefore, the maximum size is flexible. That is, we can the size is not fixed here in dynamic data structure. Array. Array comes under dynamic data structure. Array is nothing but collection of similar type of data values under a continuous memory location is nothing but array. Now let's go for dynamic data structure. In dynamic data structure, we have linked list, stack, queues. These all comes under dynamic data. In linked list data structure is a linear data structure where elements need not be stored in continuous memory location. That is, element can be stored in any location, but there will be a link between one element to the next element. It's nothing but linked list data structure. Here, each element is represented by a node. Node, what is a node? Node consists of two fields, that is, data field as well as address field. Data field. What is data field? Data field is nothing but the actual value is stored. And the address field. Address field is nothing but it stores the address of the node or address of the next node. Is nothing but linked list. In linked list, we have different types of links those are single linked list, double linked list, circular linked list. These comes under linked list. Now, what is single linked list? Single linked list. In single linked list, only two fields are placed, that is data field as well as next field. Here, the linked list, which is only in forward, it is navigated in the forward direction. Here we have only one link that is forward from one node to another node. It's nothing but single link. Now double links. Double link list consists of three fields. Node consists of three fields. One is data field, and other two fields are nothing but address fields. One address field is the which store the address of the previous node, and another address field is which store the address of the next node. This comes under double linked list. Circular linked list the same way, but here the first node address will be pointing to the last node address, and the last node address will be pointed to first node address. Here in circular linked list, we have two types. Those are circular single linked list, circular double linked list. In circular single linked list, the last node address field normally linked list, the last node address field will be null, right? But in circular single linked list, the last node address will be filled with the first node address. That is nothing but circular single linked list. Now, circular double linked list. Circular double linked list. In circular double linked list, the null fields where they represent the first node previous field is filled with null, and the last node next field is filled with null. Those null values are replaced with the first node previous field is replaced with the last node address, and the last node next field is replaced with the first node address. This is nothing but circular double linked list. Now let's talk about stack. What is stack? Stack is a linear data structure in which insertions and deletions are done at only one end. Here, normally stack follows the principle last in first out, that is LIFO. Here, for example, let's take let's take a stack of books, stack of coins. Here, the last book which we place, that would be the first one that we want to retrieve. That is last in first out. Here, normally in stack, the insertion and deletion operations are performed only at one end. That end is called top. We have different operations on stack. Those are push, pop, display, display. These are the stack operations. What is push? Push is nothing but inserting an element into the array, into the stack is nothing but push. Pop is nothing but deleting an element from the stack is nothing but pop. Display is nothing but displaying the elements of the stack. Normally, stack can be implemented using arrays as well as links. Stack using arrays. A stack data structure can be implemented using a one-dimensional array. But when stack is implemented using array, then only a fixed number of values it can store by using array. Here, normally if the stack is full, how we can say if the stack is full? Here, the top is equals to size minus 1 is nothing but stack is full. That is nothing but stack overflow. And what is stack underflow? Stack underflow is nothing but when the stack is not full, that is, it is empty, is nothing but stack underflow. Here, we can implement using linked list also. Stack implementation using linked list can organize as many data values as we want. Every newly inserted element is pointed by top. Whenever you want to remove an element from the stack, simply remove the node which is pointed by the top by moving top to its previous in the list. This is stack using linked list. Now let's talk about queue. What is queue? Queue follows the principle FIFO, that is first in, first out. Queue is a linear data structure in which insertion and deletion operations are performed at two different ends. The insertion is performed at one end called rail, and deletion is performed at another end called frame. So here the operations are, here we have different types of operations. They are MQ, DQ, and display. What is NQ? NQ is nothing but to insert an element into the queue is nothing but NQ. DQ is nothing but to delete an element from the queue is nothing but DQ. And display, we already know. What is display? Display is nothing. The element that we want to display from the queue is nothing but display. This is queue. You have different types of queues. But let's talk about queue implementation. Queue using the arrays, as well as you can implement queue using links. Queue using array. It can be implemented using one-dimensional array. Insertion and deletion are done into the array by using FIFO with the help of variables friend as well as rare. Initially, both friend and rare are set to minus, which is the queue is empty. Whenever you want to insert a new value into the queue, increment rare value. That is, we are incrementing the rare value by 1 and then inserting at that position. Whenever we want to delete a value from the queue, want to delete a value from the queue, then delete the element which is at friend position and increment friend value by 1. You understood, right? Here we are saying that your insertion is done at rare and deletion is done at friend. This is the main concept of queue. Now let's talk about queue using links. Queue using links. Here, the same way we can in normal in stack using links. Here we also implement queue using links as well. We have different types of queue. That is circular queue, priority queue, and other different types. Now let's talk about circular queue. Circular queue. There was one limitation in the array implementation queue. If the rare reaches to the end position of the queue, then what we have to do, if the rare reaches the end position of the queue, there might be possibility that some vacant spaces are left in the beginning, which cannot be utilized. So to overcome such limitations, the concept of circular queue was introduced. The circular queue was introduced. Here, the rare is at the last position. Let's say the rare is at the last position of the queue. We try to insert the element. Then it will show that there are no empty spaces in the queue. Normally, there are empty spaces in the queue, but still the rare is pointing at the last position. But when we want to insert, what we get, the queue is full. So at that moment, what we have to do, this is the solution to avoid such wastage of memory space. So now in normal array, in normal queue using array, this is the limitation. That is we are wasting the memory. So we are talking about circular queue. Now, in circular queue, what we are doing, the queue is in the circular format, right? So here we can again, we can move the rear pointer to the first position where we can insert new element where the space is empty. Here, that is nothing but circular queue. Now, let's talk about priority queue. Priority. It is similar to queue. It is similar to queue in which each element has some priority value associated with it. The priority of the element in a priority queue determines the order in which elements are survived. That is, the order in which they are removed. That is nothing but priority. The properties of priority are every element has a priority associated with it. An element with higher priority is removed or processed before an element with lower priority. If two elements of same priority are processed according to their order in which they were inserted to the queue, the priority of element is decided by its value, is known as implicit priority. The priority number is assigned with each element is known as explicit priority. Understood, right? Now, this is nothing but priority queue. Okay. Now we have different types of priority queue. That is ascending priority queue as well as descending priority queue. Ascending priority queue. It's a collection of items in which items can be inserted abruptly, but only smallest element can be removed. Understood, right? Now, descending priority. It is a collection of items in which insertion of items can be done in any order, but only largest element can be removed. Is nothing but descending priority queue. Now, let's talk about another priority. Let's talk about another queue that is nothing but D queue. DQ is nothing but double-ended queue. Here, both insertion and deletion operations are performed at either end of the queues. That is, we can insert the element from the rear end and front end. Also, deletion is possible from either end. That is, your insertion and deletion can be done at any end, either front end or as well as rear end. Now, here we have different types of decodes. That is input restricted key as well as output restricted key. Input restricted key. In input restricted key, in input restricted queue, insertion can be performed at only one end, while deletions can be performed from both ends. That's in input restricted queue. Insertions can be performed at one end, or deletions can be performed at any end. In output restricted queue. In output restricted queue, deletion operations can be performed at only one end. And well, insertions can be performed both ends. There's nothing but output restricted queue. Understood, right? Now, operations performed at DQ. What we said that the insertions and deletions can be done at any end. That is at center or rail. Your operations for operation performed at DQ are insertion at center, insert at rail, deletion at center, and deletion at rail. These are nothing but the operations in DQ. Now, let's talk about trees, which comes in a non-linear data structure. Tree is a non-linear data structure where data in a tree are not stored in a sequential manner. That is, they are not stored linearly. For this reason, the tree is considered to be non-linear data structure. Normally, the basic terminologies in trees are node. Node is nothing but element of a tree. It consists of information as well as link path. Root node. Root node. Root node is nothing but the topmost node of a tree, or the node which does not have any parent node is nothing but root node. Now, other terminologies of tree are edge. Edge is nothing but a connection between two nodes, are nothing but edge. Parent. Parent node is nothing but node with branches from top to bottom is nothing but parent. Child node with edges from bottom to top or branches of parent are nothing but child. Sibling nodes. Sibling nodes are nothing but child nodes of same parent node are nothing but sibling. Leaf nodes. Leaf nodes, what are leaf nodes? The nodes which do not have any child nodes are called leaf nodes. It doesn't have any nodes to it. Is nothing to child nodes to it is nothing but leaf nodes. Internal. Internal node is nothing but a node with at least one child. Is called internal. Now let's solve ancestor of a node. Any predecessor node on the path of the root to that node are called ancestor of a node. Understood, right? Now let's talk about degree of it. Degree of a node. Number of children nodes present are called degree of a node. Now, the maximum degree among all the nodes in a tree. The maximum degree of all the nodes in a tree is nothing but maximum degree of a tree. Now, let's talk about height of a tree. What is height of a tree? The longest part from root node to the leaf node of the tree is nothing but height of a tree. Height of a tree. But better talk about height of a node first. Height of a node is nothing but the longest part from the node to a leaf node is nothing but height of it. And that goes to height of a tree. Height of a tree is nothing but the longest part from root node to leaf node is nothing but height of it. Now, depth of a node. Depth of a node. What is depth of a node? The longest part from the root node to that node is nothing but depth of a node. These are nothing but different tree terminologies, and the different trees also, like binary tree, full tree, complete tree, and different types of trees we have. Normally, let's talk about a binary tree. What is binary tree? Every node in a tree should have at least two children. It's nothing but binary tree. That is, every node in a tree which have at most two children is nothing but binary tree. Right? We have different types of tree traversals also. In-order traversal, pre-order traversal, post-order traversal. What is in-order traversal? In-order traversal is nothing but first we visit all the nodes in the in-order traversal method. First we visit the left subtree, after we visit the root, after we visit the right subtree. Now let's talk about pre-order. Pre-order is nothing but first visit the root, after visit the left subtree, as well as the right subtree. Post order is nothing but first we visit the left subtree, after visit the right subtree, after visit the root. Understood? These are nothing but trees. Graph. Graph is a nonlinear data structure consists of vertices as well as edges. The vertices are also referred to as nodes, and the edges are lines that are connection between those nodes on a graph. We have different types of graphs: undirected graph, directed graph, and other types. Directed graph, where the edges are where the edges are here. Here the edges are here the edges are represent a specific path from some vertex A to another vertex B. In undirected graph, edges are not associated with any direction. It's nothing but undirected graph. Now, thank you. That's it. Thank you.